Hi. Today in this video we are going to see one topic from theory of machines, how to construct a velocity diagram for a 4-bar chain. Okay, let us see one example. From that we will try to construct a velocity diagram. Okay, so in a 4-bar chain ABCD, AD is fixed and is 150 mm long. The crank AB is 40 mm long and rotates at 120 rpm clockwise, while the link CD equal to 80 mm oscillates about D. BC and AD are of equal length. Find the angular velocity of link CD when angle BAD equal to 60 degree. So this is the given example. For this we are supposed to draw the velocity diagram. Before going for the velocity diagram, first you have to draw the space diagram. So here I have already drawn. I will explain how to draw the velocity diagram. You have A, B, C, D points. AD is fixed, okay, and the length of AD is 150 mm. So you have to draw a line of length 150 mm and fix the point A and D. Okay, then the crank AB length is 40 mm and the angle between BAD is given. You can see here angle BAD is 60. So fix 60 degree here and draw a line of 40 mm and fix the link AB. Okay, this is input link, or you can call it as crank. Next you have to draw the intermediate link. So from point B you have to measure 150 mm using compass. From point B you make an arc here. Okay, similarly from point D you measure 80 mm using compass and just make an arc here. So BC arc will intersect with the DC arc, you will get point C. Okay, so once you get the point C you can draw a straight line. This is intermediate link, this is output link, this is fixed link, and this is input link. Okay, so the direction of rotation of the link crank AB is given. It is rotating at clockwise direction, and the speed of the crank is also given. It is at 120 rpm. Okay, so once you know the speed of the crank n, you can easily find what is omega. Once you know the omega, you can find what is the velocity of the input link. Okay, so we are going to find the velocity of point B with respect to A point. Okay, for any link the velocity of point B will always act perpendicular to this link. Since the link is rotating clockwise direction, so the velocity of point B will be acting perpendicular to the direction of the link. So perpendicular direction means almost exactly 90 degree. So you have to place, and you can see the direction of, this is the velocity direction, this is velocity of B. Okay, so velocity of B with respect to A point, it will be acting in this direction. So let us construct a velocity diagram. So before that, once you know the value of the link, okay, so first we have to calculate what is the velocity of this VB. Okay, once you know the value, then you can start constructing the velocity diagram. So to find the value, to find the velocity of the link VB, we have to do some calculations. We know the value of speed. Okay, so I will write here, then you will easily understand. So here speed n is given, which is equal to 120 rpm. Okay, so n you know means you can find what is the angular velocity omega. Okay, radians per second. So you know the value of n, then 2 into pi into 120 divided by 60. So this will give 12.568 radians per second. Okay, so next you have to calculate the velocity for the link AB. You can see here, here the velocity will be acting in this direction, perpendicular direction. So we are supposed to find the velocity of the link AB. So that is velocity VP equal to, the formula is angular velocity into length of the link. Angular velocity is omega B into length of the link AB. Okay, so omega is what, 12.568 into, so the length of the link, this one you can see here, the length of the link is 40 mm. So convert this 40 mm into meter, so you will get 0.04 meter. So your overall velocity of the link will be around 0.502 meter per second. Okay, so this is the value, velocity of the point B, velocity of point B with respect to point A. Okay, so here the velocity is acting in this direction, perpendicular. Okay, so now we have find what is the value of this one, velocity of B. So once you know the velocity of B, then you can start constructing the velocity diagram. Before constructing the velocity diagram, you have to convert this meter per second to centimeter. Okay, then only you can draw in the sheet. Okay, so we will assume that 0.1 meter per second equal to 1 centimeter. Therefore 0.502 meter per second equal to 5 centimeter. So this is the scale I am taking. Okay, now the meter per second has been converted to centimeter. It is very easy. Now we can start constructing the velocity diagram. Okay, so now I hope you can see now the 4-bar chain. Now we are going to construct the velocity diagram. This is space diagram. Okay, this is space diagram. So from the space diagram only we are going to draw the velocity diagram. So here AD link is fixed, so I am going to fix a common point here. This is representing the link AD. Okay, next we are going to construct the velocity of B point. Okay, velocity of B point. Why it is acting downward? Since it is rotating clockwise, it is acting downward. Okay, so we are going to draw the velocity here. The value is, already we have found, it is 5 centimeter. Now what you have to do, place your ruler here at point B. Place your ruler like this, perpendicular to this link AB. Place your ruler. Okay, perpendicular at point B. Now slowly move towards this point AD. Move towards this point AD, and the length of this one, length of this velocity we have find here as 5 centimeter. So 1, 2, 3, 4, 5. So this represents velocity of B. Okay, this B we have drawn here. So this is velocity of B point with respect to A. So already we have fixed A here. So this will represent B. Okay. Next, moving to the next link. Next link is BC. Now this velocity we have find out, and next we have to move to point C. So point C velocity will be acting perpendicular to this link BC. We don't know which direction. I am going to draw like this. So it will be acting perpendicular. Okay, so once the input link rotates clockwise, automatically the next link will try to rotate in anti-clockwise direction. That means it will act upward direction. So from point C with respect to B, the velocity will be acting upward direction. The point B is here. Now place your ruler and slowly move towards the point B. Okay, and just draw a line like this, because we don't know the length of this velocity. Okay, we just extend the line like this, and the direction also. Next, coming to this next output link CD. So since this end is fixed, so no velocity will be here, and the velocity of C point with respect to D will be acting perpendicular. I am just drawing the direction of velocity here. So I told you, when input link rotating clockwise, the other link will be acting anti-clockwise. When this is rotating anti-clockwise, and this will be rotating clockwise direction. So the direction will be in this direction. Now place your ruler here and slowly move towards the point D. Since C with respect to D, already D is here, so from here you have to generate a line like this. So this velocity will intersect at this particular point. So this is C, so A, B, C, D. Okay, so now our velocity diagram is over. This represents velocity of B, CD, CB, velocity of CB, and this represents velocity of D. Okay, CD. Now in the question, what they are asking is, we are supposed to find the angular velocity of the link CD. We are supposed to find the angular velocity of the link CD. So to find the angular velocity omega, what are the things we have to find? We need length of the link. Okay, so omega equal to velocity divided by length. Okay, we have to interchange. So to find the length, here you can see DC, this is the distance, velocity distance. So measure it using a ruler. Okay, and it may comes nearly around 3.8. so 1 2 3, so it may come nearly 3.8. you can see here 1 2 centimeter, 3 centimeter, 3.8 centimeter. So velocity of CD by measurement, velocity of CD equal to 3.8 centimeter. Now we have to convert this velocity into, this is in the form of centimeter, convert into meter per second. Okay, so already we have taken 1 centimeter equal to 0.1. Now this is 3.8 centimeter. So to convert 3.8 centimeter to meter per second, you multiply 3.8 with 0.1 meter per second, you will get in terms of meter per second. I will show you the calculation. Okay, so this is to find the angular velocity of the link, last link CD. So by measurement we find that velocity of CD equal to 3.8 centimeter. Okay, so by converting we will get 3.8 into 0.1 meter per second, we are getting it as 0.38 meter per second. So to find the angular velocity of the link VCD, so the formula is, velocity formula is VCD equal to omega into CD into length of the link CD. Okay, the length of the link is, this is the length of the link, actual length of the link. Now rearranging the above equation, we are supposed to find this one omega. Okay, rearrange it, you will get omega CD equal to VCD by CD. VCD is what we have found here. Okay, 0.38 meter per second, and actual length of the link is 80 mm. We have converted that 80 mm to meter, so you will get 0.08 meter. So once you substitute these values, you will get 4.8 radians per second. Okay, so this is the angular velocity for the last link CD. So this is what they are asked in the example. So I hope you might have understood how to construct the velocity diagram for a given 4-bar chain. Okay, so thank you very much. We will see one more example with some other mechanism in the next video. Thank you.